Good morning, students. Today we are going to study about the one of the new concept that is termed as an what here? Kirchhoff's law. You already know that the Ohm's law is used for a what here? A simple circuit which is consisting of a resistor and a one battery. We can able to find out the potential difference and also what is that resistance we can able to find out. But for a complex circuits, just I will show you the one of the complex circuit here. So like this, the current which is the pass through in every node here, and also if it is the current is the pass in this manner. Okay, so here is the one resistor is there, here is another resistor is there, here is another resistor, and the batteries are connected here. Okay, here the V1, V2, V3. In such a cases, how to calculate the potential difference and how to calculate the resistance, unknown resistance, and how to calculate the what here? So current. So we have the one law is termed as an what here? The Kirchhoff's law, or we can call it as an Kirchhoff's rule we have. Before we going to study about the Kirchhoff's laws, we recover to know that node or a meaning of a what here? Junction. What is the meaning of node? A node or a junction is a point where the two or more currents meets. Let us consider there is an many number of currents. I will show you this diagram here. Okay, we have I1 is the one current, I2, I3, and also the I4. There are many number of current which is the flows through, and this particular point, what I am showing is the O, is termed as an what here? A node. There are many currents which meets at this particular point. So let us consider here is the I1 is flowing like this. This is the way. So the I2 it is going away like this. I3 it is going away in this manner. And then I4 it is also the going away like this. So this particular point is there now, this O is termed as an what here? A node. We can call it as an what here? Node. There are many number of nodes we can able to identify with this one. Okay, here we have A, B, and also the C are the what here? Node. So that is the first and foremost point we need to study. And the next point is that the mesh, or what I can able to say, a loop, a closed path for an electric current, a closed path for an electric current. Let us consider this is the one example here. Okay, this one is the example. When current is the flowing like this is the closed paths. This is termed as an what here? A mesh, or I can able to say network of circuit. Then you already know the last point, that is termed as an what here? The electrical network. What is the meaning of electrical network? Electrical network which is consisting of resistors, SLs. Okay, these are all the things which is the circuit is consists of. So that is what we termed as an what here? Electrical network. Now let us consider the first and foremost the law is termed as an what here? Junction rule, or we can call it as an what? Kirchhoff's first law. So the Kirchhoff's first law is a very simple law we have here. Okay, at any junction, the sum of the current entering is equal to the sum of the current leaving the what here? That node, that junction. So where is that particular node? Node is here. So you already know this. This is the node. Okay, so just I am showing this is the node. So it is entering. I1 is entering. I2 is the going out. I3 is the going out. I4 is also what is that? Going out. So therefore I can able to say I1 is equal to minus of I2, minus of I3, minus of I4 I can able to say. So, therefore, the sum of the current entering is equal to what here, the sum of the current which is leaving this particular node is termed as an what here, the first law of what, the Kirchhoff's law or a first rule. This is also termed as an what here, the current rule. We can call it as an what, current rule. Here what happens, the sum of the current which is comes inside and the sum of the current which is goes what here, outside or leaving the node. During this time, so what happens, the conservation of charges or takes place, or we can say the conservation of what, the current. This law is also termed as a conservation of what here, the current. So, this is what the first law of Kirchhoff's. Okay. Let us pass on to the what here, the second law of Kirchhoff's. It is also termed as an what here, the loop rule. Loop rule. So, what it says, okay. So, let us consider the algebraic sum of all voltage and also the potential difference in a closed circuit is equal to what? 0, is equal to 0. The algebraic sum of all voltage and also the IR, EMF, we can say potential difference and also the EMF in a closed circuit is equal to what? The 0. So, we can able to mention this one as what here? Delta E is an EMF and also this is voltage. E can be written as what here? IR plus delta V is equal to what here? 0. Here the sign conventions are the very important here. So, let us consider the one sign convention is like that. When a resistor R is travel opposite to the direction of the what here, the potential difference, then it is termed as in what here? The positive, in opposite direction. So, like this, okay, A and R is here. So, just I will to make you to understand, okay. So, 1 minute. So, here we have, this is the direction, here is an R, this part is considered as what here? The B. Now, it is always considered as positive. So, observe this particular part, where the resistance travel opposite to the direction of the what here? Current. Current is moving in this direction, but resistors travel in opposite direction, then we can call it as an what here? Positive. If in a given circuit, when a current R is travel in the direction of the current itself, in the direction of the what here? The current itself, then it is termed as an what here? Negative. So, this is negative, current direction is this side, this is becomes a negative, and then current direction is this side, this is becomes a what here? Positive. In the same manner, in a given circuit, okay, the source E, that is called E, this is the source E, is travel negative to the positive, negative to the what here? Positive. Then the V is taken as what here? Positive. In another case here, when a source E is travel from the positive to what here? Negative. The positive to what? The negative. Then it is V is considered as what here? Negative. So, V is considered as what here? Negative. So, let us consider the one illustration for this. Okay, we have this one, A, B, C is the one network. Apply the Kirchhoff's the second law for this, A, B, C, A network, A, B, C, A network. Let us consider the current is passed through A, B and also to the B, C and also the C, A. So, that is why A, B, C, A. So, we have, let us consider this one as I1 R1 because it is becomes a minus here. Okay, minus I1 R1, minus of this one is becomes a V1. So, current is in opposite direction. So, therefore, V1 plus of, let us consider from B to C, I2 R2, it is becomes plus. So, here also V2 is also becomes a what here? Plus V2. Then from C to what here? A. So, the C is becomes I3 plus I3 R3 plus of what is that? V3. Sum of all these things is equal to 0. Therefore, I can able to write this one as, rearrange this particular formula. So, therefore, I2 R2 plus I3 R3 plus of V2 plus V3, that is equal to, this will comes this side means positive I1 R1 plus V1. So, this is all about the second law of Kirchhoff's. So, Kirchhoff's second law is also termed as the conservation of what here? So, this energy takes place. Okay, conservation of energy, and then that is called conservation of water current, the first law. So, these are the two losses we have. So, that these are termed as in what? Kirchhoff's losses. Okay. Thank you for watching the videos. Thank you.